This is Carly, and I'm here to present my final lesson plan with a circuit, and it's going to be a hands-free flashlight. So the engineering design process started with the question, how can cave explorers see to explore new caves that they have discovered? It is grounded in the fact that third graders in my school go on a field trip to the Indian Echo Caverns, but this can be used with grades 3 to 5, which is what I teach. So students would then come up with the answer in a discussion about how the answer to the problem would be a light that must be hands-free so that the explorers can see in the darkness while also wielding the necessary tools needed to clear the paths. So the students would continue to imagine a solution by starting to build circuits on the simulation. You can see from the top one, when there's 2 lights, they're brighter than when there are 4, which students can then start to use that information to guide their planning process. As you see, I listed my materials and I made a plan to have my circuit on one sentence strip and then another sentence strip to cover it, only leaving a hole to let the light through, and having 2 separate parallel circuits, each lighting 2 lights. So here's my creation. You can see that the positive runs and then the negative runs back to the light for both, and the lights light up because I matched up positive on the light to the positive strand coming from that part of the battery. And then you can see that I put the cover on top to hide the circuitry, only showing the light. When I went to go test, because the goal was to see which hands-free flashlight could see the farthest in the cave, I did struggle to find a dark spot in my apartment because we have big glass sliding glass doors, so that was letting light in. And it was hard just looking to see where the light ended. So what I downloaded was a photometer that measured the lux, and I took it from the start of the light and as far until it read 0, and that's how I measured the distance that the light traveled, which was 22 3/4 inches. And there's a picture of me wearing it, as my kids would do on their field trip. You can read more about that in my lesson plan. So ways that I'd improve it, if I were to try it again, would be to be more lights, but less lights on each circuit to hopefully increase brightness, and then maybe a circular cover like you see on flashlights that would focus the light forward, because when I would try to go in like the bathroom, because it was more dark in there, darker in there, it would just light up the whole room, so it was kind of hard to determine how far forward it was lighting and find an absolutely dark place to test it. So if I assess or analyze my lesson based on Tool 5.1, they're assessing a real problem that relates to them because it's a problem related to cave explorers that they were going to take the role of as they go on their field trip to Indian Echo Caverns. Students are not given a prescribed way to create a circuit in order to create their hands-free flashlight, so it accepts multiple approaches. And by integrating measurement as well as circuitry, it's a mixture of important science and math concepts. And students are engaged in the engineering design process in order to create their model, hands-on, working as a team, which is why those are marked yes. And the role of technology comes into play both with the simulation and with the added test using the photometer app on the phone or other device. And does the lesson include testing the solution and evaluating the results? Yes, as in testing the brightness and determining ways to improve that. And then students are communicating their results and using that to create their final light that they would take with them on their field trip. Thank you, and I look forward to seeing yours.